Define the following term, the term mole. Yes, please. Anyone who knows, yes. Yasin, can you answer, Yasin? Yes. Anyone else? Ahmad, Ahmad Jamal. Just a minute. Yes?
Yes, Mr.
Yes, Mr.
What do you mean by the term mole? Yes?
Mr. An element?
No? Yes? Mole is a quantity of matter. Yes? Who can tell him what do you mean by the term mole?
Yes, Mr.
Yes?
Mr. It is a molecular mass expressed in grams.
No. No, this is not the meaning of the term mole. Okay? This is not the meaning of the term mole. Yes?
Mr. Can I answer?
Mr. Can I answer?
Yes. Yes, yeah, Muhammad. Muhammad.
Mr. Number of particles in 12 gram of carbon 12.
It is a quantity of matter that contains number of particles in 12 grams of carbon 12 is correct. Quantity of matter that contains same number of particles as in mole. Quantity of matter that contains same number of particles as exactly in what? As in exactly 12 grams of what? Carbon 12. Yeah. You can say quantity of matter that contains 6.02 times 10 to the power 23 particles. Clear? Quantity of matter in 1224 decimeter cube of gas at room temperature and the pressure. The first one I recommend or the second. You can say mole equals to what? 1 mole equals to mR in or AR in grams, but it depends. Clear? Okay? So, mole is a quantity of matter that contains same number of particles as what? As in exactly 12 grams of carbon 12, or mole is 6.02 times 10. Can we say 6.0 here in this question? No, because they asked us about Avogadro's constant. Avogadro's constant. What is Avogadro's constant? Yes?
6.023 multiplied by 10 to the power 23.
Just this. 6.02 times 10.
Mr. Present the screen.
تبع ساعة من البريزنت.
I'm presenting. Are you all seeing the screen or not?
Yes.
Yes, Mr.
Yes, Mr.
The one who doesn't see the screen, refresh your page.
Mr. Any digits after the two make a difference when calculating the number of particles or moles?
What do you mean? I didn't get your question.
Mr. If you use 6.02 and Mr. if you use 6.023 and the rest, Mr. Does it make
no 6.022 something, or sometimes they write it 6.023 more accurate. 6.0 they take it at 6 as the 6.0. It depends on the given. Clear?
Okay.
You got the answer, I think. So it depends on the given, what they give you. So mole is a quantity of matter that contains same number of particles as in what? 12 grams of carbon 12. And as Muhammad said, mole is number of particles in 12 grams of carbon 12 accepted. Clear? Which two of the following contain same number of molecules? This is very important question. How do we solve such questions? Yes. 2 grams of methane. How many molecules are there in 2 grams of methane?
Mr. Mass
Yeah.
over MR.
Mass over MR. What do we find by mass over MR?
Number of moles.
Number of moles. I need number of molecules. So we have this relation. We have number of moles. We have number of moles equals to mass over MR, and we have this relation, number of moles equals to number of molecules, this is molecules, over Avogadro's number, 6.02 times 10 to the power 23. We cannot find number of molecules from mass. We can find number of molecules from mole. Always number of mole is the center of our work. Always keep in your mind, if number of moles is not given, to find any quantity first, you need to find the number of moles. Shall I repeat? To find any quantity, if the number of moles is not given, the first thing to do, find the number of moles. We have mass. From mass, we divide mass by MR, we find number of mole. From number of moles, we find number of what? Molecules. We multiply the quantity that we calculated by what? By 6.02 times 10 to the power 23. Clear?
Yes, Mr.
Okay. So, to find number of moles, always we divide, except one case. In case of concentration, we multiply concentration by volume. So here, 2.0 grams, 2.0 divided by MR of this, which is 16, equals to what?
0.125.
Right. This is number of mole. When we find number of mole, we multiply it by what? 6.02 times 10 to the power 23, then we find the answer. Clear? Okay? Yes? Then we do the same for oxygen.
Sir, the number on the left is the number of moles, right?
The number on the
It's
left?
2.0 over 16.
Yes, this is number of moles. After we find number of moles, we multiply it by Avogadro's number, we find number of molecules. Clear?
Mister, it is 7.5.
7.5
7.5. 3 times 10
to the power
to the power of 22.
22 molecules. Yes, anyone who didn't get it? Then for the second one, Ya Omar, Usama, can you do it? Yes?
Yes, Mr.
Can you solve for oxygen?
Yes, Mr.
Yes, how to solve it?
Mr. To find, you must find the molecules, so you multiply the n times the 6.02 times 10 to the power of 23.
So first I need to find N. How to find N?
Eight over 16.
Why you
Yeah.
divided 8? Yes, 8 over what?
No, Mr. 32.
Yes, because we are finding what? The molecules. MR of this is what? Is 32 multiplied by 6.02 times 10 to the power 23. Clear?
Yes, Mr.
So, what is the answer?
Mister, it's 1.5 times 10 to the power of 23.
1.5 times 10 to the power
10.
20. Yes. What about ozone? Yes.
Mr. 2 divided
Yes,
by 6, Mr. 2 divided by 48, multiply by 6.023.
6.02 times 10 to the power 23. Yes.
Mister, it's 2.5 times 10 to the power of 22.
2.5 times 10 to the
Times
power
10.
22 molecules. Clear? And for sulfur,
Mister, 8 over
Mr. 8 over 32 plus 32.
32 plus 32, you mean 64.
64.
Yes, sir.
Times 10, 6.02 times 10 to the power 23 equals to what?
7.
7.525 times 10 to the power of 22.
Mr. 7
So the two that have contain same number of molecules are what?
Methane and sulfur dioxide.
2 grams of methane and 80 grams of this. Agree?
Yes, Mister.
Look, here in this question, show how you arrived your answer. You need to calculate the number of moles. But if this question is multiple choice question, okay, clear? No need to multiply by 6.02 times 10 to the power 23. Just find the number of moles and compare them. Why?
So can you repeat again?
If this is a multiple choice question and they ask you which two contain same number of molecules or which one has the greatest number of molecules, then find N and compare. No need to find number of molecules. Why?
Mr. They have the same mass?
For the same number of moles and we're multiplying by a constant, so it will give us the same answer.
Equal number of moles of any substance contain equal number of molecules. Equal number of molecules, because 1 mole of methane contains 6.02. 1 mole of oxygen contains 6.02 times 10 power 23. 1 mole of ozone. So the rule is that equal number of moles, okay, contain what? Contain equal number of molecules. This is a rule.
Molecules.
Clear?
مستر كان في صوت طلع من جوجل ميت.
Like what?
ممكن واحد عشان كان عايز يدخل.
Someone.
لا أستاذ مين ده؟
Ahmed Muhammad. Who is he?
No, Mister, I don't know.
Ahmed Muhammad. Let me see.
كان مضيع.
Ahmed مين أنت? Who are you? Ahmed Muhammad. Ahmed. 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 Who are you, ya Ahmed? Where is he?
بس أستاذ يمكن ما يكون خربان.
مين هو؟ A student command.
أستاذ
نعم.
مش تقوم تفكر إنه أنا
لا، مين هذا؟ أحمد. I will remove him.
DVT.
Okay. Ahmad Muhammad.
نعم أستاذ.
I accepted him. Do you know why? Because two students must join our class. Mr. Bakur gave me their names. I don't remember the names now. Because of that, I thought he is one of them. Okay? So let us continue. There is a rule: equal number of moles of different substances contain equal number of molecules. Okay, do you remember yesterday I mentioned that 1 mole of any substance is occupied in same volumes?
Yes, yes.
1 mole of, when we say 1 mole for every substance, what is the number it contains? 6.02 times 10 to the power 23. 2 moles, so we multiply this by what? By 2, and so on. So if we are comparing, is there any necessity to multiply by this number if it is the same in all?
No, mister.
No. So when they say compare, no need to multiply by what? By this number.
Sir, can you show us a question about this, because I didn't really get your point.
Yes, I will show you a question. Okay? I will show you a question about this. How come I explain and leave it floating like this? Okay? It will not work. I will show you the question about this. Okay? You will see the question here. Yes, we have it here. Okay. Which of these contain same number of, yes, this is the question. Do you see it? Question 10.
Yes, sir.
Which sample contains what? Greatest number of molecules. So there is comparison here. When there is comparison and it is multiple choice question, to solve it quickly, no need to multiply by what? By Avogadro's constant. It is only what? A step of finding number of moles. Number of mole of hydrogen, number of moles in 4 grams of hydrogen. How many moles do we have? 2. For water, 1 mole. For O2, 1. For CO2, 1.5. If we multiply all by 6.02 times 10 power 23, will this make any difference in our comparison?
No.
No. So only if we find number of moles, it is enough to make comparison about number of molecules. Have you got it, ya Omar?
Yes, Mr.
Omar.
Yes, Mr. I got it.
So if the question is multiple choice question, then no need to multiply by this. But if it is structure question, then there is necessity to do this. Okay? Clear?
Yes, Mr.
Look at this part C. The given is what? In decimeter cube. So I found what? I divided this by what? By 24. Okay? Clear?
Yes, Mr.
أستاذ
Yes.
مستر ليش الام ار ل O2 24
Where is O2?
O2 هي O2 يعني oxygen.
Look at the question, part C. What do we have in part C?
24
Decimeter cube. So I divided what?
Master concentration and volume.
V over 24. This is volume of gas.
okay مستر thank you.
Clear? I said, look at C before you ask. Okay? Here the given is 24 decimeter cube of gas. So this is the volume of the gas, not volume of solution. Okay? Assume that we have this question, question 11. Okay? What is the concentration of 10 grams of sodium hydroxide, okay, solution, if the volume of the solution is 250 centimeter cube? So I need to find what? The concentration. How to find the concentration? First of all, I need to find what?
Number of moles.
Moles.
Always, if it is not given, first find number of moles. Number of moles of what?
NaOH.
Of the solute, the substance dissolved in the solution. What is the substance dissolved in the solution? NaOH. Excellent, Ya Muhammad. So what is the number of moles of NaOH? We have mass. We divide mass by MR. MR of NaOH is what?
40.
Go to the periodic table, you find it 40.
Mr. The mass is 1, not 10.
1, so it is excellent. 0 point, it is 1. It is 0.025. 0.025. 0.025. So now we need to find the concentration. What is concentration? How to find it? Number of moles divided by what?
Volume.
Volume. Volume must be in what? Which unit?
Decimeter.
In decimeter cube. So divide this by 1000. It will be 0.250. So what would be the concentration? Yes?
0.1.
0.1. I showed it down. Okay? Clear? Okay? What is the concentration of ascorbic acid when one tablet is dissolved? Same question or not? In different exam. What is the concentration? Also same question. The concentration of hydrochloric acid is this. How many moles? So I need to find the number of moles. What is the given? The given is the concentration and what? The volume. Okay?
Mister, we just times it by volume.
Yes, number of mole equals to concentration times volume. The volume must be what? Divided by 1,000. Clear? What is the value?
0.0125.
0.0125. Okay? Clear? Okay?
Okay, Mister.
So, use the data sheet to calculate the mass of what? Of 1 decimeter cube of hydrogen gas at room temperature and pressure. What is the mass of 1 decimeter cube? What is the given here and what is the required?
Or we want the mass and
The given is what? Volume of oxygen is 1 decimeter cube. And at room temperature, we know the volume of 1 mole of any gas at room temperature is 24 decimeter cube. So number of moles equal to what? 1 divided by what?
24.
24. Clear? I need what? Mass. Mass equals to what? Number of mole times
The MR.
R. So multiply this by what? By MR, which is 2. Is it difficult?
Sir, can you repeat it again?
Yes, I can repeat. Look, Ya Omar, we need the mass of what? Of 1 decimeter cube of hydrogen gas. Hydrogen gas is H2. Okay? We need the mass. What is the given?
Mr.
1 decimeter cube of gas at room temperature. So at room temperature, as if they told us, use the volume of 1 mole of a gas as 24 decimeter cube. First of all, can we find the number of mole of this gas?
Yes, Mr.
So because we can find number of mole, we multiply it by MR, then we find what? We find mass. Number of mole for gases, N over V, V over 24. This is what? This is the number of mole. Multiply it by MR, which is 2. Clear? Then we find how many grams the mass of 1 decimeter cube.
Sir, are you talking about Mr. Hydrogen, Mr. Molecules, right?
Yes, because they are saying 1 decimeter cube. We cannot say 1 decimeter cube of atoms. Okay? 1 decimeter cube, either gas or solution. So 1 decimeter cube of hydrogen at room temperature and the pressure, it means what? This is a pure substance, not solution. They are talking about an element, the element hydrogen, the element oxygen, okay? About a substance, element or compound, not solution. Clear? If they say what? Calculate the mass of 1 decimeter cube of methane. What is methane? It is a compound, CH4 gas. We are not talking about solution. Solution is a mixture. Okay?
Yes, Mr.
Got it?
Yes, Mr.
Okay. Now, this is a good question. Arsenic 3 oxide. What is the formula of arsenic 3 oxide? Yes.
Mr. AR2O3.
AS. Arsenic is AS. Okay? AS2O3. Okay? Clear? Arsenic, as far as I remember, it is periodic table.
استاذ في past paper question من 1994.
Hey, I have all these.
ايوه استاذ.
I have all these. So, it is arsenic AS. Okay? AS2O3 is very poisonous. It was used to kill Papias III in the 15th century. The lethal dose is 0.130 grams. How many lethal doses are there in what? 1.40 gram of this oxide. This is easy. How to solve this question? Yes. If we divide the total mass by the mass for each one dose,
Mr. 8.
we find how many doses. Do you remember when I divided MR by AR for carbon, for selenium, I found how many atoms are there in this mass. Okay, the same, we divide the total mass, or you can say every one dose 0.130 grams, 1.40 grams, how many doses? Okay, clear? Okay.
Yes, Mr.
So the question below is similar. The idea that I have just given above. Fullerene is an allotrope of carbon. One of fullerene has the relative molecular mass. This. How many carbon atoms are there in one molecule of this fullerene? Okay. number of atoms is. So what is the number of atoms? How to find it? It is
MR over AR.
MR because it is an allotrope of carbon. What do you mean by allotrope of carbon? Made up of carbon only. Allotropes are different forms of the same element in the same physical state. It is made up of carbon atoms only. So I divide 720 by 12 equals to what? 60. Clear?
Yes, Master.
Then I think I solved this question with you. Didn't we do this? Nickel has the formula this. Its relative molecular formula is this. Calculate N. How to find N? We solved this.
Mister, we solve for MR of NiCO.
Yes. This is nickel CO. I think it was Ni.
Mister, it's 14 plus 16.
It was like this or the same like this.
Yes, Mr.
Was
It
it-
was like this.
Like the given or the one I have just drawn?
Mr. I think the one you have just drawn.
I think like this. Okay?
Yes, Mister.
Yes, so it is like this. So how to do it? When MR is given, okay, and we need to find any unknown N, what do? We write the MR in terms of N. Do you remember?
Yes, Mister.
What was nickel? Nickel, its AR is 59. 59 plus what? Plus
Plus 14.
14 plus 16, it is 30. 30N. We do it this way better. Equals to
Equal
what?
to 172.
2. So 30N equals to 172 minus 50.
Mr.
Nine.
12 plus 16 is 28.
Yes.
Mr. Isn't carbon 12?
28. 28. You are right. I did it quickly. How I wrote this 30. Excellent. So always be with
Mister,
me.
it's
28. Yes. What is N now?
not, N is equal to no, Mister. I mean 28. N is equal to 113, and
130.
N is equal to 4.
Okay. Clear?
Yes,
I'm going to correct this. Please C-O-N. I will just correct it.
Mr. Should we get Mr. a whole number here, or can we get a decimal?
Whole number. You cannot find decimal. If it is, for example, 4.1 something, so whole number.
Mr.
Okay.
We got
Mr. Isra.
4.035.
How much? 4?
4.0357.
So it is 4. Clear?
Okay.
Whole number. In the
Okay.
formula, we cannot write other than whole numbers. Okay? Yes. Now, before going through this, I will go to the empirical formula. What is the empirical formula? Is the formula which shows what?
Mr.
This
Why was
Whole
writing a
number
decimal
ratio
number
between the
wrong?
atoms.
So the smallest whole number ratio between what? Between atoms. So empirical formula.
Mr. Why would be writing a decimal number be wrong, Mr.?
Where?
Because, Mr., it's a subscript, Mr., for the question about nickel.
Nickel, what did we do?
Mr., I'm asking, should it be a whole number because it's a subscript?
In the formula, we chose the whole number. The formula either shows the actual whole numbers of atoms in one molecule or shows the whole number ratio. Always in the formula there are what? Whole numbers.
Okay, Mr.
Clear? If it is for molecule, then actual. For empirical formula, it is what? It is whole number ratio. Okay?
Okay, Mr.
Okay, so empirical formula, like here, we have it here, the empirical formula. Yes, I have a question here. Sample of iron contains 50 grams of iron and 21.6 grams of oxygen. What is the empirical formula? How to find the empirical formula? Yes, the empirical formula, if we have masses or percentage by masses, then we divide by AR to find the number of moles of atoms. Here we have oxygen. Oxygen is a gas, so we divide this by what? 21.6 divided by what? 16.
16.
So those who are in class, always in finding the empirical formula, what do we do?
Mr. Tariq,
Yes.
the class is over, Mr. And Mr. Assam Tahini is waiting.
Yes. In finding the empirical formula, we divide by what?
Mr. I have to leave now, Mr.
Divide by AR. Don't forget it. Okay? I will continue from this point because of that. Okay? Empirical formula. Agree?
Mr.